Hey everybody, this is Longo, and in this video we are going to cover taking complex roots of polar numbers. And this is going to be a little throwback to the last video with Dumov's theorem. Instead of raising something to the n power, though, we're going to raise it to the 1/nth power because we know the square root is the same as a 1/2 power, a cube root is the same as a 1/3 power. So this theorem is still going to work. I wrote it just in the shortcut form because we are going to be working in polar only. So there's no need to make you guys write out a bunch of stuff. That's why we use CIS, okay? So basically, if we take a complex number and raise it to a 1/nth power, we're just going to, same thing, we're going to raise our radius to the 1/nth power, and then instead of multiplying theta, we're going to divide because we're multiplying by the 1/nth power. But special note, when we are finding all of the different complex roots, we are going to need to also divide 360 or 2 pi divided by our root as well, because we're going to have multiple. So kind of like, you know how the square root of 4 is plus or minus 2 if you're solving. There's 2 of them. Well, when we take a cube root in polar, there's actually going to be 3 answers. If we take a 4th root in polar, there's going to be 4 answers. And you'll see in just a minute. So what we need to do here is take the complex root, or find all the complex roots of 27. To do that, the first thing you need to think about is where is 27 in terms of polar? And that would be 27 plus 0i. So this is our x value. So we're going to be out here. This is where 27 is, and that is, of course, our radius. No need to do the Pythagorean theorem here because we have a 0. It would just be 27 squared plus 0 squared is equal to r squared, and we'd square that and we get 27. So we know that r is equal to 27. So now we just have to use our formula here. So our theta out here on the x-axis, we know that our theta is 0. So now we're just going to use it. So we have 27 to the 1/3 power because we're taking the cubed root. And then we're going to have our CIS of our angle divided by 3. So that would be 0 divided by 3. And we're going to do this in degrees. So that simplifies to 3 CIS 0. So that is our first one. Now, our initial term is going to be z sub 0. Remember, z sub 0 or a sub 0 from back in other units means the first term. And what we need to do now is we need to figure out all of the other ones that happen along polar. So since we are doing a cubed root, we are going to take 360 degrees and we're going to divide that by 3, which means each of our intervals is at 120 degrees. Okay, so we have an interval at 120 degrees. That's where our other ones are going to take place. So at 120 degrees, you are going to have another one. And we would call that one z sub 1, which means our first interval afterwards. And we get 3 CIS 120 degrees. And then after that, we're going to go 120 more, which is going to take us to 240. And that would be our z sub 2, or second interval, would be at 3 CIS 240 degrees. And you know, if you added 120 to that, you would be back at z sub 0 at 360 degrees, which is the same as 0 degrees. And that's it. That's all you have to do to take a complex root of a number. So this next example here, what we're going to do is we're going to solve for x, which is the same as the previous type of question. It's just written a little bit differently. If we were to solve for x, we would be taking the fourth root of both sides. So what we're doing here is taking the fourth root of 81i. So to start this question, you're going to do the same thing. You're going to start by graphing. And if you would like, pause the video and see if you can handle this one on your own. If not, here we go. This would be 0 plus 81i, which means that's our y value. We are up here. Again, there is no need for you to do the Pythagorean theorem. R is going to be equal to 81 because, again, 0 squared plus 81 squared is going to end up giving you the square root of 81 squared, which is just 81. And now our theta, though, we are up here on the y-axis, that is 90 degrees. Okay, so just like the last example, what we are going to do here is we are going to raise, since we're doing the fourth root, our first step is going to be to take 81 raised to the 1/4 power, CIS, and then we're going to have 90 degrees divided by 4. Okay, so that means our z sub 0, our first answer, is going to be 81 raised to the 1/4 is 3. CIS of 90 divided by 4 is 222.5 degrees. Okay, so our first one is going to be right out here. But then you have to remember we need our intervals. So we're going to do 360 divided by 4 this time, which means our interval is every 90 degrees. Okay, so our next one, z sub 1, is going to be 90 degrees past 22.5, which is going to take us to 112.5. So this is going to give us 3 CIS of 112.5 degrees. Our next one is going to be 90 degrees from there. So add another 90 to that, and you're going to be at z sub 2 is at 3 CIS 202.5 degrees. And then we need to get our fourth interval, which would be down here. So z sub 3, or our third interval, is at 3 CIS 292.5 degrees. And then if you added 90 back to that, you would be past 360. However, that would just take you right back to 22.5. Okay, if you added another 90 to this, you would be at 385 or 382.5, but that would just be 22.5 past 360 and go back to 22.5. Okay, so really that's it. Taking the complex roots of polar numbers is really not that bad. So anyway, this is your last video for the polar unit. This is Longo and I'm out. See you, bye.